All right, good afternoon, everybody. If you're here, you are here to talk about disconnected environments. Either that or you are a glutton for punishment. Start by introducing myself. I'm Dan Moch. I'm a staff software engineer with Lockheed Martin. I work out of Orlando, Florida.
I'm Zaneski. I'm a software engineer at Defense Unicorns, and I'm based right here in Denver.
And again, we're here to talk about air gaps. So let's start with the obvious question. What is an air gap?
Who saw the keynote this morning? The Edge keynote? Yeah. Okay, some familiar folks, right?
So the term, I would argue, has sort of a formal definition and then an informal one. Formally, a network is air-gapped if there's no connectivity to the rest of the world, right? So there's no ingress, there's no egress. Effectively, SneakerNet is the only way to get data in or out of that network. Informally, we call networks air gaps sometimes if they have a very limited kind of ingress, but still no egress. Ingress in this case would be through a specialized device called a diode, which if you're familiar with electronics, you know that a diode only allows current to flow one way. And that is what a data diode does, only it does it with data. So we can have this sort of informal concept of an air-gapped environment using a data diode to sort of sit in between that network and the rest of the world. And that's how you would have an air-gapped environment in a cloud provider, for instance. Egress traffic in general, never allowed in an air gap. Ingress might be allowed through those specialized devices that I've already mentioned. And again, if you have a highly secure network operating at some level of classification, there's a decent chance that it will be completely physically disconnected with no ingress or egress apart from SneakerNet.
Some places in the world where you might find an air gap, defense, if you're working with the government in any sort of capacity. Generally, government computers can't be connected to the internet, though we've all seen all sorts of compromises when they are. Financial institutions, lots of banks have their networks locked down, especially some of the ones that are running a lot of the back end, like trading stuff. All of that is pretty isolated and air gapped off. And then something like a certificate authority, right? Like your actual super root CA for your certificate authority probably should never be something that is connected to the internet. Does anyone work in air gap environments regularly? Wow.
All right.
That's way more than I expected, huh?
Yeah, it's cool.
Yeah. Shout out the industry. Defense, government, a lot of defense. Cool.
Any non-defense folks? Healthcare.
Healthcare.
Great.
Super common.
Telecommunications.
Yeah. Ironic, but yeah. Very cool.
Okay, so I've already hinted at this, but yes, you can have an air-gapped environment in the cloud. I don't know if I have anything else to say about this. Cloud providers are increasingly offering in their government offerings these data diodes so that you can create a quasi-disconnected network or an air gap. User access through these networks is interesting. You might think there is no way for a user to access a network if you're going through a diode. Of course, we have AWS workspaces, we have Azure virtual desktops. Those are the mode of interaction with systems on those disconnected networks. And the advantage of them would be that you're basically accessing it through a remote desktop session or through a web browser, and any feature that would allow you to copy data off of the target systems onto your own local machine is turned off, so that that's simply not possible.
Yeah, and there's always this partition between an actual physical air gap and a virtual one, right? Where we're relying on software controls or network hardware to maybe make these bridges for us. So, and one of the really pain points of working with air gap tools, right, is we live in such a connected world that as soon as you go into an environment that you just can't pull things from the internet anymore or look things up, you have to come up with new ways to solve familiar problems, right? And that's sort of the premise of this talk, is talking about these different things that we've encountered that are novel or interesting problems to tackle that we might take for granted as developers who can just open our laptop and go to GitHub and download something, versus folks who are stuck in a SCIF or a secure room all day.
Yeah, so there's a lot of us that have experience already working in disconnected environments in this room, in air gaps, but for those of you who haven't, this will hopefully give you a flavor for how to develop software to actually work well in an air gap.
Yeah, and we've all, been on an airplane or not been on Wi-Fi somewhere and, ran a simple tool or a Docker pull or a Git pull, and everything just kind of explodes because all of our tooling just assumes that we're connected to the internet when we go to touch those things. So lots of interesting things we have to work through.
That's right.
And so data management is a big one. We kind of broke this down to a bunch of different ways. Anyone familiar with the term sneaker net? Yeah, it's this idea that, how do we get data into a secure environment or into an air gap? Well, we would either take a USB device or a DVD, put what we need on there, and physically walk it to the computer and plug it in. That's what the DoD calls sneaker netting. There's also, we mentioned these types of one-way NFS mounts or diodes. These are where we're relying on software controls and maybe some networking hardware to be able to only send packets in one direction. And so this lets us do things like maybe mount something as an NFS mount on our workspace that we can drop files in, but can't read or pull anything out of. In a lot of government environments, and I'm sure financial and other places too, you're not allowed to plug anything physically into the computer. So you are stuck with DVDs. I would wager that the US government is probably one of the largest consumers of DVDs still to date, because we go through lots and lots of them. And then there's this interesting term called classified couriers. You want to tell a story about that, or?
Oh, well, so a classified courier, this idea that if you burn classified data onto one of those DVDs, like we were just talking about, you're going to carry that between classified environments. You're going to walk out of the SCIF, you're going to walk it over to another one. You need to go through some special training and be certified in order to do that. I have never been a classified courier, but I have had to work with classified couriers. When you're debugging software and having to write it in one environment and debug it in another environment, you don't make friends with the couriers in those situations. So that's just it's something you want to try and avoid. I think the data diode has come around kind of since then, and that's been a great enhancement, so we don't have to bother those couriers all the time. Still need to use them if you're physically walking things out of a SCIF, but that's the need for that has dwindled somewhat since the data diode.
Yeah, you can imagine what it would be like to have a secure room next to another room and need a secure escort to go between the rooms carrying your data. So yeah, lots of fun there. And then backups are always super interesting, right? We take for granted being able to back up to the cloud, S3, Dropbox, all sorts of things, but when all you have is you're protected in your air-gapped environment, the only place you can really back up to is in your protected and air-gapped environment. So how do you back up? How do you run things? There's other tools like Minio, and we'll get into some other tooling, right? But we need to find different ways to be able to take our data and store it in our place. And this idea of having all these off-site backups, generally not possible when we're stuck in an air gap that is a completely disconnected environment from a different one. So yeah, a lot we take for granted.
One of the things that we tend to take for granted working outside of the air gap is bootstrapping. It is a common thing when you first boot up your laptop after you've received it to go and download the software that you actually want to run on it, whether it's non-vendor web browser or something else. A lot of software installs today, I'm thinking open source and also commercial software, it more or less assumes that you have connectivity to the internet. To such an extent that I was part of a team once working with a company providing a Kubernetes solution, and they were rolling major versions, and their new version did not support installing in a disconnected environment. We ended up having to switch away from that vendor ultimately because they couldn't get that working in the time frame that we needed. Which is to say that you might be leaving money on the table if you're a vendor by not providing any means to install your software that's disconnected. So think providing a software package that I can either burn to a DVD or push through a data diode and then completely disconnected installation after that. That's something that's important for folks working in air gap.
Yeah, and if you're used to working with Kubernetes, one of the things when you spin up a Kubernetes cluster is it expects to be able to pull down things like the Kubernetes networking pods. It expects to be able to pull the pause container, which is part of every other container, right? So there's just a lot of like dependencies that sure you might have installed Kubernetes, but Kubernetes by default still expects to reach out to the internet to download some of those initial containers. Anyone ever have to fight with time inside of an air gap before? Yeah, there's some very unhappy hands in the air. Normally your computers, your servers, all sorts of things, even your company might run their own NTP infrastructure, right? Network time protocol. And we take time for granted so often, but being able to synchronize time across all of our computers and systems is really complex, especially when you have no source of truth that you can get from the air gap, right? One of the systems that I work on, we have these like servers that are isolated, and we have these Android tablets that are brought out to the servers. And so you can imagine both of these things need to be relatively close to the same time, but they can't get time from one another. And so what you wind up with is all sorts of certificate trouble, because certificates have a not valid before and a not valid after timestamp. So when you're stuck with systems that you don't have accurate or up-to-date time, you have to do all sorts of interesting things like maybe set your laptop's computer to like 3 years in the past so you can generate a certificate that's actually valid. Not that I've had to do that often. Same things with like time to lives, right? We work with all sorts of different TTLs for different projects, database TTLs, table TTLs. Those TTLs will drift slowly, especially, let's say that these environments might be powered off at some point, right? And maybe they do or don't have a hardware clock. Not being able to synchronize time amongst themselves and other things, you really just kind of have to make do what you have. And that's really like how we've learned to work with system time, is you really, as long as you have one source of truth that you can depend on and hopefully sync everything else to, even if it's like 5 years in the past, just by having everything roughly on the same time will save you a ton of headache.
Proxies. All right, so this is an interesting topic, sort of air gap adjacent, some might argue. Applications, especially when they are not, say, networking libraries, they tend to do a pretty good job of respecting network proxy settings. But if you're working on one of those libraries, then you need to pay attention to that, right? Because in settings where you're working in disconnected environments, again, proxy is a bit adjacent to air gaps per se, but a lot of the same folks are going to be, when they're not in that air gap, working behind a proxy. Your network library needs to be able to understand and respect the proxy settings on those users' machines. Some proxies will go a little bit further and inspect TLS traffic, and that's a good thing for security, arguably, but it does mean that if you are pinning certificates and you have no way to sort of trapdoor out of that, or that's probably not the right phrase, there's no way to sort of point to a different certificate revocation list or a certificate chain, that's going to break your application, right? So because these inspecting proxies will actually grab traffic on one end, terminate the TLS connection, do their inspection, and then they'll open a new TLS connection. So you're actually, as an end user, connecting to the proxy, not to the end server. Other than the TLS certificate, it will look somewhat transparent to the user. But again, that to say, if you're pinning certificates, you're kind of broken. So again, I think this is sort of air gap adjacent and appropriate to talk about because a lot of people dealing with air gaps are also going to have to deal with these, particularly TLS inspecting proxies.
Yeah, and we mentioned that we have like the formal definition of air gaps and these informal definitions. And a lot of those will rely on proxies to make things usable, where you have to fight against, the environment you're working in. DNS is another example. DNS actually usually depends heavily on being able to proxy, where you can actually have your DNS server, if you're able to run one, do that intercepting of routing, to a locally hosted in your own network type of thing. That gets all sorts of interesting, again, when you do have certificate stapling and pinning. Anyone have to fight with the HSTS preload list before? Yeah. In the back, of course. So this is a set of domains that are kind of like hard-coded into major browsers that say these domains will only ever be able to be talked over HTTPS. So .app is one of these, .dev is one of these. There's all sorts of other ones. But by default, if you've ever used a .app or .dev domain, you have to talk HTTPS over it. It will actually, the browser will refuse to visit a site, and that's not HTTPS. It'll forcibly redirect. And so that gets really interesting when you're stuck in an air gap where you have to do all this proxying and intercepting to maybe make some tooling work. Lots of fun. And then again, like, where do you get this DNS? Are you able to run one locally? We've all had to fight with DNS in different sorts of ways. And should you cache it, and how long should you cache it for? Your IP space might change often, it might not change at all. Networking in general, from DNS to NTP, you have to really, I don't know if there's any like best practices. Sure, there might be best practices you can follow, but like no one has said like, yes, this is how we do it, and we're like really super happy with it. So it really depends on the environment and what you can get to work with it.
Another air-gap adjacent issue is the issue of hardening. A lot of these air-gapped environments are not just dropping COTS software with no further configuration into the network. They are doing a lot of intentional hardening of those systems over and above that. You've got SE Linux policies. If you are working in the defense contractor space, you're probably going to have to look at NIST SP 853, in addition to stigging guidance. If you work in commercial space and you're dealing with credit cards, you'll have to do with PCI, DDIL. These are all various standards that folks, many of them working in air gaps, are going to have to follow. And those hardening requirements can subtly break the expectations that we usually make when we're writing and maintaining software. So there's no easy guidance coming out of this. I'm mentioning all this more to create some awareness around that.
Okay, so now you understand some of the basics and the fights that we have to do when we're working inside of an air gap. Then there's the whole idea of trying to build software in an air gap, right? You might be working, like we said, for a defense customer or a financial institution or a healthcare institute where the environment you're working in cannot be connected to the internet while you are writing and developing software. There are ways that we try to bridge this gap by trying to do as much as we can in the live side, as we would call it, and then bring that into the high side to do maybe the last bit of integration. But one of my first experiences, I'm relatively new to working with the government, and I went to a hackathon on an army base, and I was working with a partner on a hackathon project who was very used to working in this environment, and we were in a secure facility, so no internet, no nothing. And my partner kept leaving the secure facility with his notebook and coming back with handwritten pages of notes. And he'd come in, type them into the computer, see if it worked or not, and then rinse and repeat. And I eventually asked him, like, what are you doing? It turns out he was going out to the parking lot to get his phone from the car to look things up on Stack Overflow, and he was handwriting the Stack Overflow code and then bringing it back in to test if it worked or not. And this was mind-blowing to me as in how are you able to get anything done, but to him who's been working in this environment for so long, it was just part of how he has to do his job. And so, when we think about that, we think about things like downloading dependencies, right? At that hackathon I went to, we had to give these folks a list of like Python dependencies we needed to be loaded into the environment. And they said, okay, it'll take 8 hours for us to scan and upload them into the environment through a diode or something secure. And so we basically lose the first day of the hackathon. Second day comes, we go to pull into dependencies, and the folks didn't actually grab the transitive dependencies of those dependencies, right? So we had pandas, but we didn't have the libraries that pandas depends on. And that's not the fault of the person that's working it. It's just that it's actually really hard to build that tree and to download that bundle of software you need to bring into the environment. So basically we lost 2 days to just getting dependencies working in this hackathon. And then, like I said earlier, some cool tools just kind of expect an internet connection. And that's just, most of our tooling today, you're not really thinking about the folks that are, I think the example I like to give is if you've ever had to work on an airplane before and you've tried to get any work done without internet, you'll realize how quickly your entire software stack and your IDE really just depend on an internet connection to be able to do anything. One of the kind of like the saving grace for on the third day of that hackathon, we actually deployed an LLM locally into the environment. And it was kind of the first moment that I realized that like offline AI type stuff is really useful in those types of situations where you can snapshot the current state of knowledge and then bring that in and be able to ask questions to it. So I thought that was like a really interesting solution there.
Okay. So we've talked a lot about the problems that we face. There are tools being developed and practices that are emerging that are designed to sort of make this process easier, make life easier for folks working in these environments. So for right now, we're going to focus on some of the tools. I can't remember if this was you or me.
You can do it.
Okay, so to be aware of is, number one is the Hopper ecosystem. This is Lockheed Martin open source. I work for Lockheed Martin, full disclosure. This is a plugin-based ecosystem, and there are a lot of tools involved. But what it is Hopper, this is all SBOM driven, by the way. Hopper will collect and bundle those dependencies, like what Eddie was just talking about. You can do that on the live side, push it through a data diode or sneakernet it into your environment, and then use Dropper to deploy those dependencies into either a registry or a local file system for use. Maybe you want to talk about Zarf, Eddie.
Yeah, Zarf is similar tool, similar space, kind of Swiss Army knife of dealing with all sorts of air gap stuff. Brent here is one of the maintainers of Zarf. We donated it to the OpenSSF last year, I believe. Yeah, similar type of stuff. Zarf actually has full support for birding DVDs, where it knows how to page out the data across multiple DVDs to be able to burn it. So you can imagine that's the type of stuff it gets used for. And just like we mentioned some self-hosting stuff, right? Just being able to go into this environment, and you might have your own development environment, you might have your own servers, but to be able to do anything productive as a developer or any sort of other tooling, you pretty much have to bring and deploy your own software, right? So when it comes to things like code repositories or pipelines, right? GitLab is used all across the DoD, the government, all sorts of other industries. I'm sure folks are familiar with GitLab, we don't have to get too into it, but GitLab actually works really well inside of an air gap. It's real nice to be able to bundle everything, deploy GitLab offline, and it has most of the functionality that you can use with GitLab, you can use with the self-hosted air-gapped version. Other tools like Mattermost, right? It's basically a matrix-type client that's very similar to Slack, and you can deploy Mattermost inside of your environment, and then you have your chat infrastructure and other sorts of stuff that all the folks that are in your air-gapped environment can work together. So there's all sorts of these other tools that you can bring your offline portability, your offline, the tooling that you're used to using offline.
So there's Eddie sort of referred to the fact that Kubernetes makes a lot of subtle assumptions, thinking about pause pods and so forth. The major one among those being that if you're doing development in sort of the internet, right? Would you call it the live side?
Yeah.
If you're doing development on the live side, you want to push everything up into an air-gap environment. You're going to end up with environmental differences between where you're developing and where you're deploying, right? These transition and intermediary tools can help with that through mutating webhooks. Image shift is one. This is a mutating webhook that will change the image references in your deployments and so forth. Or in your Helm charts to point to whatever your private OCI registry is within your air-gap network. Zarf, I think, has some similar functionality on its own. Zarf, as Eddie said, is a Swiss Army knife tool, so if you're using Zarf, you may not need image shift.
Yeah, and William Crum here is actually a developer of ImageShift, really cool project, but this idea of how do we make our existing tooling work in an air gap where we can abuse things like mutating webhooks in Kubernetes to override values, and you wind up working with that type of stuff a lot where you have to override a tool and tell it, hey, you're used to looking for here, but you actually want to pull your data from here. So, there's all sorts of different platforms that we've worked with. We've talked about Kubernetes a bunch, so K3s, RK2s from the Rancher open source folks. There's also K0s, very similar project. They have FIPS, FIPS implementations based on your requirements for FedRAMP and other stuff. But these are all really great tools that let you bundle all of those initial Kubernetes containers and stuff into kind of like a big zip file that you can then bring into the air gap. And again, if you look at, I think it's actually interesting to show where we have, let me show you this. So K0 has like a list command that it can list all of the built-in containers that it actually expects to be available, right? And it's more than you would imagine from Kubernetes out of the box. But when we compile Kubernetes upstream, we don't build these containers into the artifacts we're shipping. So you actually need to figure out how you're going to get this list of software bundled and be able to use in the air gap. And I lost my notes. There we go. Is that right?
Yep. Okay, so we've been talking about the problems and the challenges that developers face working in air-gapped environments. I'm going to talk to us now as open source developers and maintainers. What can we do to help? Again, don't expect an internet connection. It's not always going to be there for the folks that are using your software. And I say that recognizing that it's actually difficult to check if you have an internet connection. Finding a reliable way to do that turns out to be tricky. Does it work on an airplane, I think is sort of the heuristic you can use there. Add options and toggles that are air gap friendly. So again, if you're doing certificate pinning, you should probably allow a toggle to turn that off for folks that are using inspecting proxies, for example. Again, respect the proxy settings. That's usually done for you. And then supply chain security. Will and I are doing a talk on Wednesday where we'll talk more about supply chain security. But the more open source maintainers who can start signing their releases in SigStore and using the tooling that the OpenSSF is kind of leading the charge developing, that's better for everybody. So I think that is pretty much it. We've got 13 minutes left. Are there any questions?
Yes.
You said sign your packages with your releases with SignStore.
Yes. So the.
Why would I use that instead of, for example, GPT, as for example I'm using for?
GPG is what you're using? Yeah, so the question was why sign with SigStore instead of something like GPG? I think the basic reason is a root of trust, right? So there's no, to my knowledge, there's no mechanism. I know there are GPG key servers and things like this, but to reliably establish identity, SigStore has a really good story around that, right? And it involves using your GitLab or your GitHub account to create an OAuth token, a short-lived OAuth token that you would use to sign the release that way. And then SigStore also has basically a transparency ledger, right?
Yes.
So any release that gets signed with SigStore, that history is sort of auditable.
Yeah, the verification of SigStore offline has a really good story behind it, where you can actually export the signed entry timestamp from the transparency log and be able to walk back and trust something inside of an air gap. And if Hayden was in the room, Hayden's one of the maintainers of SigStore, he can talk all about how that works, but it's much easier to be able to snapshot the SigStore transparency log and bring that in for offline verification. So.
And I believe there are, if you're working in GitHub at least, I think there are GitHub actions that will make creating that signature package as simple as possible, I believe.
Why don't you just develop everything on the low side, compile it like a modern language like Go or Rust, and then push up the binary package, use synthetic data on the low side so you can replicate, and then just, push up the final product?
Great question. Why don't you develop everything in the low side and then compile, bring that in, use synthetic data to be able to test it and push it up?
My answer is, as much as possible, I think that's what we should be doing. Partly just because of all the challenges that we've been talking about, that slows down development cycles. And as I can tell you as a defense contractor, we're under as much pressure as anybody else to make our products cheaper. And that's good because, of course, it's the public that's paying for those in large part. So developing faster, I think, means developing on the internet as much as we can just to have all that data accessible, right? Now, there are things that we just can't develop in an open environment. I think that's probably what you're alluding to when you're talking about use synthetic data. If there are any algorithms that are classified, of course, those would also have to be developed on the high side. But as much as possible, I think that doing development on a public network, I shouldn't say public network, connected network is a good thing.
Yeah, one of my biggest realizations while coming into the world of the government was everyone tends to think that the problems they're solving are super unique, and it's not true at all, actually. Industry has been solving these same problems since I've been a developer, and I'm sure even before then. The reality is maybe like 20 to 10% of their problem is actually the secret part. The problem is the developers and the people who want to do this aren't the ones making the rules and policies, and those people say you've got to be in a locked room with no windows.
You can have windows, they just need to have blinds on them. That's
Yeah.
right. Yeah.
When working in an air-gapped environment, my experience is that no one planned to have the facilities to have a development environment established in that air-gapped environment. Do you have to advocate for the next project to have it, or can you advocate how do you advocate to have the current project add that kind of thing with no budget for it?
I'm going to rephrase your question a little bit to make sure I understand it. So your question is, with all the things that we could be doing, setting up GitLab and Mattermost to have a good development environment within the air gap, how do you advocate to actually get that stood up?
In your experience, do you have the opportunity to advocate for that in the middle of a project, or do you have to wait for the next project so that you can tell someone to budget for it?
I think that that really depends on the contract and the way that procurement is being done for that contract. If it's a fixed cost contract, you may your hands may be kind of tied. If it's cost plus, you may be able to negotiate and get funding to stand up an environment like that. I'm assuming this is a program that's been around for a while, and none of these tools were really around when things got kicked off. So I would hope that there would be a chance at some point, given that this program has already been around for a while, I would hope there would be a chance at some point to say we need funding to actually stand up a useful development environment so that we can work faster and better. Alan.
Yeah, that was a great answer. What I've seen be really effective is like just the measurement of deployment frequency and like how much time does it take, when you don't have the right tooling in your air gap side to make a small change, see if it's the right change, build the next version of the software and test it. And you can. I've seen so many programs that didn't realize how much developer time they were spending waiting for the next build or waiting to test something that they just fixed. When you show them this is how much time you're wasting, this investment will reap reward in 5 weeks.
Yep.
All of a sudden, people who do not want to spend on your environment suddenly get very excited about the opportunity.
Yeah. So we had someone chime in helpfully to add that that case gets a lot easier to make with your customers if you're actually measuring how long deployments take, and I guess making some data-driven recommendations for how you could bring that number in by improving your development environment.
Yeah. Anyone who's probably worked with government contract before has heard the term ODC, other direct costs on a contract, where it turns out that it's much harder for the government to purchase something than to say, hey, defense contractor, we're paying you, so maybe use a tiny bit of this money to buy this thing we really want for us. And it's just the way that bureaucracy works sometimes. So yeah, we try to do what we can.
Yeah. Question over here?
To that earlier question, something that we found to be particularly productive with these return clients is first phase, you can do it outright said. The second phase, you get them to build in, hey, listen, you're not going to pay us any extra, but we're going to build in this tooling. You're just going to authorize us to build in this tooling. We're going to show you the difference between A and B, and on C, E, F, and G, you're going to pay for that tooling to be installed.
Yeah, that's good. That's good. A lot of these tools, GitLab and so forth, have sort of annualized licensing costs. So you could, this is again going back to the question of how do you make the case to your customers to actually go and pay for these things. Well, you could choose to bear the cost yourself the first year, and then you could actually show the customer how much faster development can be. Did I get that right? Okay. Thank you. Yeah.
So for those open source developers working in non-SCIF environments, other than telling them to disconnect from the internet every month and see how their software works, which is probably a good idea anyway, is there any other kinds of advice you could tell them?
Okay, any other advice other than unplug from the internet once in a while, see how your software behaves? So this is advice to open source developers. Yeah. Right, okay. A lot of us are involved in building distributed systems in some way, shape, or form, right? So there's some interesting issues that arise when you're building a distributed system. I think we've touched on some of those already, the issues with time and DNS and so forth. Be aware of what specialists in distributed computing systems are saying about those issues. I think most of them will tell you that time is a tricky thing to make hard assumptions about, right? So this is, I guess what I'm advocating for is look at what folks. I'm blanking on his name. There's someone out of AWS who does a pretty good job summarizing these sorts of distributed system concepts and. But just read the papers, read the blogs. There's a lot of good material out there. I think awareness is probably just the big thing, right? Keep your head up.
Yeah, my biggest request is to, I had it here somewhere. Respect proxy. So really just use standard libraries. Standard libraries for most of the languages today will make all these things work out of the box. They'll pick up on things like environment variables for like the SOX 5 proxy. It's really, you don't have to generally get fancy with using, implementing a lot of this yourself. As long as you're using standard libraries, I know Go does, Java does, Python does. Almost every major programming language will respect most of these settings if you're using their built-in networking libraries, for example. So that can go a long way by not rolling your own network libraries.
So along those lines, let's say you're using standard libraries. If for provisioning, if you just can you're making software to be installed in a customer air gap situation, can you rely on, as long as you're, the package managers, can you rely on those as being an abstraction where, like, in a non-air gap, they'll pull remotely in an air gap, or like, in other words, can we just trust that, or else are there any gotchas that we have to do extra hoops to make sure we can support that transition?
Yeah.
Developing software, vendor software is particularly.
Right, so if you're developing for an air gap, how do you get things like package managers, packages from Linux or PyPI? Did I summarize that right? Yeah, so there's really the two options. One is to mirror all of that yourself into the environment, which is easier said than done, especially the bootstrapping portion of that is how do I get the entire PyPI library into the environment? The other is use tools like we mentioned, like Hopper, Dropper, Zarf. All of these work in a way of like being a declarative package manager, where you can, on the live side, declare all of your dependencies and use one of these tools to reach out, bundle everything up into a zip file, and then that gives you one artifact that you can bring across the air gap.
And in the case of Hopper, at least, you can deploy those extracted libraries on the high side to, say, a Nexus server or something like an Artifactory and host it that way.
Yeah. We might be out of time, actually. We're happy to hang out up here and answer any other questions. Thank you all for coming.
Thank you.